Hi guys, welcome back to the yet another episode of a series of engineering documentaries. In this episode, we'll take a look over the general information and about engineering aspects of Bogibeel Bridge, which is the India's longest rail-cum-road bridge. So let's get started. Bogibeel Bridge is a combined road and rail bridge over the Brahmaputra River in the northeastern Indian state of Assam. This bridge is 4.98 km long, which reduces the travel distance for the people of Arunachal Pradesh and Assam. Before this bridge came into reality, people used to travel by ferry to cross the Brahmaputra River, and that transportation is slow and difficult too. Bogibeel Bridge is the fifth longest bridge in India after Bhupen Hazarika Setu, Dibang River Bridge, Mahatma Gandhi Setu, and Bandra Sea Link. But it is the longest rail-cum-road bridge in India and the second longest rail-cum-road bridge in Asia. This Bogibeel Bridge has strategic importance, which facilitate faster movement of troops to Arunachal Pradesh, that is the country's easternmost Indian state that shares a border with neighboring country China. The bridge gives easy and direct access to Upper Assam from the rest of the country through Brahmaputra's north bank, so that due to its location, bridge has a strategic importance to India. The bridge is designed to withstand tremors up to 7 and beyond on the Richter scale. So to offer the good stability to the heavy spans of Bogibeel Bridge, spans are provided with seismic restrainers. Bogibeel Bridge spans the Brahmaputra River and connects the town of Dibrugarh on the south side of the river to the Dhemaji, which is the north side of the river in the state of Assam. Now let's take a look over the project history of this project from its initiation to completion. The Bogibeel Bridge traces its origin from Assam Accord of 1985. It was sanctioned by the Government of India in 1997 and 1998. The foundation stone of this bridge was laid in year 1997 by then Prime Minister H.D. Deve Gowda. The construction, however, started only in 2002 when then late Prime Minister Atal Bihari Vajpayee inaugurated the construction works. However, the work did not begin until 2007 owing to the lack of funds and attention. Consequently, that same year, the Bogibeel Bridge was granted a national project status by the Government of India in 2007 by the Prime Minister of that time, Dr. Manmohan Singh. Accordingly, the Union Ministry of Finance funded the 75% of the project cost, while the Ministry of Railways financed the rest. The bridge witnessed huge time and cost overruns over the time. The cost initially estimated at 1,767 crores, which escalated to Rs 4,996 crores by 2014, and the overall cost of the project ultimately escalated to Rs 5,960 crores. And before the end of 2018 in December, the whole construction is complete. And on 2nd December 2018, the first freight train crosses the Bogibeel Bridge. And on 25th December 2018, the present Prime Minister Narendra Modi inaugurated this Bogibeel Bridge. Various contractors are involved in the construction of Bogibeel Bridge. The state-owned consultancy and the project management enterprise RITES, Rail India Technical and Engineering Services, undertook the pre-construction studies, geotechnical investigations, and the detailed design of the railroad bridge. Bhartiya Infra constructed the guided bunds and the approach embankments on the south bank of the river. The contract for the construction of foundation substructure of the bridge was awarded to the Gammon India in April 2008. A joint venture of Hindustan Construction Company HCC, German-based DST Brockenbau, and VNR Infrastructures was awarded to the contract to construct the superstructure of the bridge in November 2011. Now let's see the construction of superstructure of Bogibeel Bridge. For the construction of superstructure, HCC set up huge facilities on the south bank of the river, which had 3 sequences of fabrication, assembly, and launching. For the fabrication of various sections of the bridge superstructure, different types of equipment are used like magnetic lifters, computer software controlled CNC plasma cutting machine, lean machine, specialized beam making CMM machine, blasting guns, spray guns, etc. And some of them equipment are imported from the foreign countries. As the bridge superstructure is a truss structure. So for that, fabrication of different parts which adjoin together in the assembly yard to form a truss. Fabricated sections are then moved to assembly shop for guided to their correct positions through jacking, and then welding is performed to assemble them. Then segments are sent to the vertical assembly. An examination of this is thoroughly made in the bridge dimension design chamber. After that, nose of launching is prepared. For launching, 1000-ton jack linked with the substructure that used to move the steel truss over the pillars. Truss slides over the launching bearings with the help of sliding plates. At the same time, 10 spans are moved by the launching, and finally, launching bearings are replaced by the final bearings. Afterwards, tracks for the railways are laid and roads are constructed over the truss by adopting RCC construction. Now we'll see the measures taken to protect the structure from corrosion. The superstructure of the Bogibeel bridge has been constructed using these special graded copper bearing steel plates to reduce the corrosion. To further reduce the corrosion due to the excessive humidity, a complex corrosion protection system specific to the different components of the bridge has been implemented during the construction of this bridge. Metal spraying by aluminium, in which the metal is melted and directly sprayed onto the surface of another metal to protect against the corrosion, heat, traction, etc. This method was used for the gusset plates and brackets. Hot dip galvanizing is also applied. In this process, coating iron and steel with zinc, which alloys with the surface of the base metal. Also, all enclosed spaces were sealed by welding and were vacuum tested so that no air can go inside and initiate corrosion. So, the location of Bogibeel Bridge falls in seismic zone 5 as per current latest Indian standard as 1893 Part 1 2016, which has been most vulnerable to earthquakes with magnitude in excess of 7 on Richter scale. So, in order to offer the good stability to the heavy spans of the Bogibeel Bridge, they are provided with seismic restrainers. This arrangement works as a male and female connection with female pockets embedded onto the piers and male parts arrangement on the span. Now let's see the overall benefits because of this project. The bridge be a big boost for the defense forces, as it can provide the rapid connectivity to the areas near the India-China border. This means quicker movement of troops and heavy weapons. The biggest benefit is the time that is going to save. Other than this route, from Arunachal Pradesh to Assam's Dibrugarh requires a 500 km of detour via Guwahati. Now the journey is reduced less than 100 kilometers. Also, the train between the Delhi and Dibrugarh will also came down from 37 hours to present via Guwahati to 34 hours. That is a reduction of 3 hours. The bridge provides direct access to the district of Upper Assam from the rest of the country through the north bank of Brahmaputra river and will do away with the need to take tortoise route through the Guwahati in the south bank. Tourist places of Arunachal Pradesh now become more accessible and give fillip to the tourism industry. Dibrugarh district also houses the prestigious Assam Medical College. The bridge will benefit interstate transportation of medical patients seeking the treatment in Dibrugarh. Previously, if any emergency of super specialty kind arises along the north bank of Brahmaputra, the patient need to rely on a boat ferry for transportation, which can be very cumbersome or dicey. The bridge connect important highways in the Assam so that it contribute to enhance interstate trade ecosystem. Previously, any cargo generated on both sides consume at least 10 to 12 hours before it reaches its destination. So before I end up this episode, let's take a look over the major highlights and the present scenario of this bridge. The Bogibeel Bridge is the India's longest Rail-cum-Road bridge at 4.94 kilometers, which reduces the travel distance for the people of Arunachal Pradesh and Assam. The bridge's lower deck has double-line broad-gauge rail tracks, and the upper deck is a road of 3 lanes. It is the country's only bridge to have the full welded steel concrete composite girders. It will enhance the national security of eastern region of India by facilitating the swift movement of defense forces. It will also provide shorter distance and alternative railway route to Dibrugarh via north bank of Brahmaputra. The bridge is a part of infrastructure projects planned by India to improve logistics along the border in Arunachal Pradesh. Due to its location, bridge will be of strategic importance to India as it will significantly enhance India's ability to transport troops and supplies to its border in Arunachal Pradesh. The Bogibeel Railroad Bridge is significantly reduce unnecessary extra cost of transportation and time through the route of railway as well as roadway.